Welcome everyone into the third day of the edition of EVConIndia. I, on behalf of Blue Circle, would like to take a few moments to thank all our esteemed partners for putting their shoulders to the event. A special thanks to our main sponsors, Log9 Materials and Hero Electric, knowledge partner Alvarez and Marcel for creating the white paper, investment partner Indian Angel Network for co-authoring the Startup Ref program, accelerator partner Huddle, and real estate partner JLL. It's been an absolute pleasure working with everyone and getting their support. Thank you also to our distinguished audience for joining us, most of whom are CEOs, CXOs, and senior leaders. Many among them are our members and are repeat visitors to our webinars. This is very encouraging and motivates us to provide even higher levels of dialogue. For those of you who are new with us today, India-based startup Blue Circle is the world's first sector-specific opportunity and knowledge exchange networking app for business leaders. It is somewhat like the sector-specific LinkedIn for senior leaders, a space to have meaningful conversations, connect with over 15,000 plus rapidly growing community of like-minded leaders from India and across the globe, exchange high-quality curated content, and access business opportunities across 20 sectors such as e-mobility, renewable energy, healthcare, and many more. Coming to today's discussion, it is a privilege and a pleasure to welcome Gautham Maheswaran, our distinguished keynote speaker, who is handpicked because of the think input and the rich experience he brings in. Gautham is the CTO and co-founder of RACEnergy. At BITS, he worked in the motorsports team manufacturing two race cars every year and raced them across Europe and India. He built his first race car at the age of 16. He was the head of manufacturing for the team and was instrumental in bringing the cars to life, from designs to performance on track within months. At RACEnergy, he brings together and leads the various branches of research and engineering, such as battery, powertrain, software, firmware, hardware, cloud computing, etc., required to build an automotive product. He currently has 4 patents to his name. The discussion will revolve around the topic, The discussion will revolve around the topic, how battery swapping will boost EV adoption while accommodating for future advancements in battery technology. Now I request Gautham to please begin the session. Thank you.
Hey everyone, hope you're having an amazing day. Thank you so much, Gautham, for that introduction. I'll quickly share my screen and we can start off. And thanks for all those who've joined in. I'll try to keep it as short as possible and we can have more of a discussion later on. I'm Gautham, co-founder and CTO of RACEnergy. We are into battery swapping in the electric mobility space. So I'll just take you through what problems exist today in the EV segment. We hear a lot, about electric vehicles, e-mobilities, but the adoption rate of these EVs has been pretty slow, to say, in India at least. We've been talking about this for the past 5-6 years. So if you deep dive into what exactly is slowing down or what's causing this slow rate of adoption, there are a few key underlying factors. The major one being the high cost of EVs that we're talking about. Why these are high? Because 50%, at least 40 to 50% of the cost of any electric vehicle that you take is the cost of the battery that goes inside the vehicle. The battery costs are going down rapidly over the last decade or so, but still the price parity between new EVs and gasoline vehicles has not been achieved. Meaning the EVs are still more expensive when you compare it to an equivalent performance of a gasoline-powered vehicle. The second reason why adoption rate is slow is because the end user has to take care of the batteries, right? So he has to charge the batteries, maintain the batteries health, has to cool them down, keep the charging rates at, within specified levels, only use specific type of chargers, etc., etc. So a lot of headache on the end user to manage the batteries, and there's a doubt or a concern about what happens to the batteries once it reaches the end of life. We're talking about maybe 5 to 8 years of battery life, and then what happens? What does the user have to replace the batteries? Does he have to pay more money for it? All these questions come up when you decide to buy an EV today. Added to this is also the lack of charging points. Public charging points are coming up, but If you talk about the number of vehicles on road, there are about 30 million four-wheelers on road in India. If you talk about two-wheelers, there are more than 200 million two-wheelers in India. So if you talk about electrification and mass, how are people going to charge all these vehicles on road? Is the grid going to support all these vehicles simultaneously charging at the same time? And charging itself has underlying issues. Not everyone has enough power availability at their homes or apartments to charge the vehicles. If you talk about three-wheelers and two-wheelers, no dedicated parking spots exist, to connect these to the grid and charge the vehicles. And on top of this is, the charging time required to go from 0 to 100% of an electric vehicle. That means you have to charge your vehicles for anywhere between 2 hours to 6 hours. Meaning you have to be waiting for the vehicles to reach that 100% charge before you can go out. And yeah, urban parking space is a huge concern in countries like India. You don't get place to park your vehicle. Forget about putting public charging places and expecting so many number of vehicles to park at the same time in the same place and charge. So all these problems put together is slowing down the EV adoption rate. And in comes the solution that we're talking about, which is battery swapping. Essentially, the end user just comes to one of the battery swapping points, exchanges the completely discharged batteries from their vehicle with fully charged ones from the battery swap station, and they're good to go on the road within a couple of minutes. What this does, it straight away reduces the upfront cost of adopting e-mobility. How? Because the battery is no more part of the vehicle. So like I mentioned, half the cost of the vehicle is just removed from the end user. If you talk about a two-wheeler that costs 1 lakh rupees or so, it comes down directly to 50,000 rupees to buy the two-wheeler on a battery swapping model. And the user just ends up paying for the energy he uses once he starts swapping the batteries when he's on road. The end user just ends up paying for the energy that he uses rather than paying for the battery upfront, which greatly decreases the cost of adoption of electric mobility as such. And he doesn't have to care about the batteries anymore. He can just keep driving, swapping at places, doesn't have to think about charging or charging times, maintaining the batteries, cooling the batteries, or replacement of batteries at the end of life, and all these just evaporates out of the equation of adopting e-mobility. And the best part about battery swapping, is it gets over within a couple of minutes. That means zero downtime to all the users that are adopting this solution. And it's very important for when you talk about commercial fleets that are on the road. Time is money on road for all these guys. So they cannot wait for charging their vehicles for hours together in the middle of a shift or something. Battery swapping works great for them because you just swap the batteries, you get 0 to 100% within 2 minutes, and you're back on the road. And also because a single battery swap unit can cater to a multiple number of vehicles at the same time, you don't need big parking spaces for vehicles to stop for hours together to charge. And added on top of this is, because the batteries are at the swap stations, they can be temperature controlled. They can be charged slowly, they can be charged fast, depending on the demand of the vehicles coming to do the battery swapping. This means there's no additional load onto the grid as such as we speak. So the battery swap station can slow charge the batteries when the demand is lower, reducing the load of the grid. And during night times when the load of the grid from the other utilization is lower, you can fast charge the batteries or slow charge depending on the requirements. So battery swapping comes in and eliminates all of the underlying issues that are persistent with battery charging or fixed battery system as such. On top of that, every day, if you read the news, if you're following the battery segment in electric vehicles, every day we hear about new technology coming up. Be it cell chemistries, there's lithium iron phosphate, there's lithium NMC, nickel manganese cobalt oxide, different combinations of chemicals that are being put in to increase the battery capacity, stability, safety, etc. So ever evolving battery chemistries come in different geometries. There are cylindrical cells, there are prismatic cells, there are pouch cells. Even inside cylindrical cells, there are different dimensions that are being used. For example, Tesla uses a 4680 bigger battery unit. Multiple others use 18650, 18650 units. These are smaller, thinner ones. So every day there's something new coming up. Every year we see something new being introduced into the market. And on top of that is the thermal management systems. Different chemistries and different batteries require different thermal packages. Meaning, for the battery to operate in a cooler condition, you need to build and develop different kinds of thermal management. All of this is not really possible if the battery is fixed inside a vehicle. Because the end user owns it, you cannot just keep getting back the battery and updating all these things as you move forward. What battery swapping does, on the other hand, is because the battery is owned by the battery swap operator or battery, and it's always comes back to the battery swap station. You can always update what's happening inside the battery. Inside the same form factor, inside the same shell that you can see for any battery pack. These what you see are RACEnergy's battery packs. We have a specific form factor. You can accommodate different kinds of cells inside the same looking unit that can go into different kinds of vehicles. Be it lithium-ion chemistries, we are talking about sodium-ion and metal-air batteries coming out into the future. All of these can be accommodated into the same form factor. Different dimensions that I talked about can go into the same form factor. And if anything comes up, say, a lot of companies use passive cooling. There's something called phase change materials to cool the batteries down. Liquid cooling coming up. A lot of people using liquid cooling. So all these solutions can also be integrated inside the same form factor, meaning all the packs will look the same from the outside, will perform the same from the outside, but on the inside, everything can be different inside battery swapping. This is not just limited to hardware. When you talk about communication systems, there's wireless communications that's being developed by a lot of companies. Bluetooth meshes coming up. All of these hardware updates can be done inside the battery pack, just because the battery is not being owned by the end user. What's benefiting the end user in this case is that he gets the best of all worlds. Every day he uses the battery, it's going to be the most updated battery pack. He does not need to upgrade it by spending more costs on it. All he has to do is go to the swap station, swap the batteries, get fully charged batteries, and be back on the road. That's the beauty of battery swapping as such. That's not it. Battery swapping has more applications. If you talk about grid support, a typical day in India, that's the average load curve that you're seeing here. There's a peak load for all the electronic appliances and industry during the evening and the mid part of the day. Battery swap stations can act as a grid support unit when this happens. What I mean by this, whenever the grid needs is at a high peak point, the batteries inside the swap stations can provide electricity back to the grid, try to balance the load. It's called load balancing. Typically, 4 to 8 batteries can power anywhere between a small building to a couple of buildings. So we're talking about power backups and grid support systems, essentially acting as virtual power plants themselves. So whenever the vehicle demand is lower, the battery swap station can go into a grid support mode. And whenever the grid needs to provide back to the stations, they can charge the batteries using bidirectional current flow through the chargers. And this goes a long way in the sustainability goals that we are having as a country, as a planet that we're talking about. Like I mentioned, the battery swap stations are virtual power plants, meaning they can supply back to the grid. And on top of that, all the vehicles that are going to be swapping are going to be IoT enabled. The battery packs are going to have IoT enabled systems in them, meaning everything is going to become one connected system. Based on all the data that comes out, the demand for swaps, the current that's going to the batteries, the performance of the vehicles, how much energy they consume from going to point A to point B. All these data points can be gathered, used to run machine learning algorithms, data science models to predict and plan cities, sustainable cities, data-driven city planning, and work towards achieving sustainable mobility goals as such. So all these are brought about by the simple fact that batteries can travel around. They're not fixed inside a specific vehicle, not fixed with a specific user. It's going to be a shared platform. The cost is going to be shared across everyone. Everyone gets a win-win out of this. The customer, the end user gets to adopt electric mobility at a very low price. The battery swap players get a cut out of it. the government and the city planners get a cut out of it, it's a huge win-win for everyone. And I hope battery swapping, the recent talks have been in support of battery swapping as such. The government has come out recently to push a battery swapping standard, giving more confidence to the end user that this is a viable business model to take forward. And I hope this clicks out in a big way, and we at RACEnergy believe we can be part of that huge chunk that takes forward battery swapping. So with that, I'll conclude the session. We'll be very happy to take any questions from any of you. Thank you so much.
Thanks, Gautham. I think a very elaborate presentation and very thorough. I really enjoyed looking at it. I'll jump on to the questions which have come. One is from Aarti. She's saying, for battery swapping to ever have a chance to becoming a mainstream technology, interchangeable battery packs that are similar for various manufacturers must be found. This can inhibit advancement in battery innovation. What is the way around this?
I'm sorry, can you repeat the last part of the question?
She's saying that this, so you want me to repeat the whole thing, or just she's asking what is the way around this?
Okay, so from what I understand, different vehicle segments will require different kinds of batteries. For example, a two-wheeler might need a smaller battery pack, a cargo three-wheeler might need a bigger battery unit. When you talk about four-wheelers, they need much bigger battery units. So all the manufacturers need not have the same model of battery swapping. The entire concept can be the same, where you exchange fully charged batteries with depleted batteries from the vehicle to and fro. Different infrastructure will come out for the same. There will be different ecosystems running in the country. Like, for example, if I want to draw a parallel, you have petrol, diesel, gasoline, gas-run vehicles, CNG, hydrogens coming up. All of these operate under the same umbrella of a petroleum retail outlet, right? The same way you will have different battery packs, different batteries being supplied to different vehicle segments going on in the future. So I think a lot of multiple ecosystems serving different vehicle segments is what's going to happen in the battery swapping segment.
Thank you. I'll move on to the next one, which is by Rajan, saying the infrastructure required for battery swapping is immense and much more complex and expensive than charging. Why is it still being considered the number one solution for EV adoption? Wouldn't it be more feasible to have fast charging stations, especially since technology is fast advancing?
Yeah, I'd like to answer this question in twofold. So firstly, like I already covered, fast charging is an option, but again, you need so many fast charging stations to cater to a lot of vehicles. Even if you talk about, 10-minute fast charging, there are going to be multiple vehicles, hundreds of vehicles coming to wait for those 10 minutes in a specific area. In a country like India, where parking space is a huge problem, it's difficult to set up these public charging places as well. And fast charging is not really feasible, in homes where you want to set up home charging facilities, because the house powered might not, support fast charging as such. You need around 20 to 30 kilowatts of power to support one single fast charging station. So that is one thing. And another thing is that battery swapping, like I said, can address or cater to a multiple number of vehicles at the same time, because multiple batteries are housed inside the same charging battery swapping unit. So just solves the problem of battery charging as such.
Thank you. I'll move on to the next one, which is a very interesting analogy plus question. It says, do you see a similarity between mobile phone industry and EVs? If yes, then initially we had batteries which were removable, similar to battery swapping. Mobiles went into fixed battery and probably a power bank, similar to opportunity charging. But today, mobiles are charged in the morning, and faster charging gives us the flexibility of not having to carry a power bank. Would faster charging and bigger size make swapping go the way powering up a mobile went?
A very interesting question there. So it's a good analogy, but a small gap in that is because we know how much power is drawn by the phone. It's highly optimized. It's taken decades of optimization to get to this point where you charge it in the morning, it lasts throughout the day or 2 days, depending on the size of the battery. But we're talking about electric mobility, right? The load in the vehicle is going to be varying. The terrains they're going to go through is varying on a daily, on a minute by minute basis as well. So you do not exactly know how much energy is going to be consumed, or how long, how much range is going to get out of one single fast charging. Is it going to last a few kilometers, a few hours in the day, or is it going to take it for a couple of days in the week? So all of those question marks lead to a point where, you need to have flexible systems. Battery swapping provides that flexibility in the sense you can swap out your batteries even when they're at 50% remaining. You can swap at 0% remaining. And when you have a network of battery swap stations, you typically have infinite range with you because you can just hop from one place to another, just like you would do with a petrol station. And again, fast charging kills the battery life. We all know this from laptops to mobile phones. It is highly recommended that we slowly charge the phones and slowly charge whatever battery you take as possible to elongate the life of the battery itself. We throw away our phones in 3 to 4 years. I'm talking about a huge range, but we cannot throw our vehicles away into 3 years' time. So we'll have to care more about the batteries when we are talking about the electric mobility segment. And fast charging is good for emergency situations, but again, it's going to degrade the battery life in the long run. That's where battery swapping comes in. In battery swapping, you can slow charge the batteries depending on the demand prediction. You can slow charge in the nights. You can, like I said, since you can hop from place to place and swap the batteries, you need not fast charge to get full range out of every battery.
Thank you. I think a very elaborate and meaty answer, I would say.
I hope I answered the question because the debate is a long one between charging, fast charging, and battery swapping. A lot of questions come around. We can talk about it all day, but I hope I answered the question that was posed.
No, you did. You did.
Yeah, and one more interesting thing is, I would say not to look at fast charging as a competition to battery swapping. If fast charging is developed in a way to, get the performance out of the cell, life cycle out of the cell with some new fast charging technology, that can be put into battery swapping as well. Because we, at the end of the day, we're charging the batteries inside the swap station. I can fast charge this batteries inside the swap station as well. The difference being the end user doesn't have to worry about any of this, and it's easier for him to adopt electric mobility because the cost of the batteries are again taken off the vehicle's cost.
Correct. So I'll move on to the last one. The question is, how does one sell the vehicle for the first time without a battery? Because just to follow up with what you just said right now. So the question, I'll repeat again, how does one sell the vehicle for the first time without a battery? Wouldn't there be commercial difficulties as OEMs might not be willing to opt for the same battery?
So there are multiple players involved in battery swapping. There's firstly the vehicle OEM who make the vehicles themselves. There's the battery manufacturer who makes the batteries. There's a battery swap operator who operates all these batteries, and probably other players for operations and serviceability and all this stuff. So when I mentioned ecosystems that are going to be found for these kind of battery swapping players, there are going to be collaborations. Multiple OEMs might opt for a few specific battery packs that they want to be used in their vehicles. So, for example, if you talk about 5 different two-wheeler companies tying up with RACEnergy to provide their vehicles on our battery swap model, so that way all the vehicles can come to any of our battery swap stations. And we are also talking about some kind of interoperability between different manufacturers as well. That's something the government is working on. If that happens, the same vehicle OEM can tie up multiple battery manufacturers, design their vehicle in such a way it's modular to accommodate different batteries under the battery swapping model. So that way the user doesn't have to worry about where do I go to swap the batteries, or the OEM doesn't have to worry about which swap provider is going to provide batteries. So I think that covers the question that we asked.
Thank you. Thank you so much, Gautam. If you don't have any more questions, just give a short ending note that thank you very much for such an insightful and engaging session. It was a privilege to hear you. And also thank you to our leaders in the audience for joining us and for staying till the end and for always sharing excellent questions. Have a good day, Gautam. Thank you.
Yeah, thank you so much. Have a great day.
Wait, I think we do have another question. So maybe just before we leave,
Yeah, sure.
companies like Revolt have already set up their swapping stations, or are in the process of doing so. How would it be any different?
Again, like I mentioned, different manufacturers are going to have their own ecosystem of battery swap stations. So it doesn't matter who's going to set it up. End of the day, it depends on which ecosystem the vehicle is going to run on. If I think Revolt was the company under discussion, if they are setting up their own swap stations, obviously the vehicles can go there and swap it. If they partner with different companies, they will also add on to the ecosystem, providing similar batteries for swapping for the same vehicle. So it doesn't matter who's going to set up the first swapping station. It matters on how the ecosystem is going to pan out, who all are going to be part of which ecosystems, which vehicles, which batteries. So that's something to look forward to.
Understood. Thank you. Thank you so much, Gautam.
Yeah, thank you so much. Yeah.
Bye.